Let's consider another problem where we're going to use the work energy theorem. We have a rifle shooting a bullet at a speed of 400 meters per second. Before you even get started, you should read this and think, I cannot ever use grams in any of the masses I've ever used. So we're going to first convert this to kilograms, and 5 grams equals 0.005 kilograms, because to go from grams to kilograms you move 3 to the left. Let's look at our first problem. We want to calculate the kinetic energy of the bullet as it's leaving the rifle. That's pretty simple, because we know that kinetic energy is 1/2 mv squared, and we have all the information we need here. Mass is 0.005, velocity is 400, and that needs to get squared. If we solve that out, you'll get about 400 joules, exactly 400 joules. Joules, kinetic energy as the bullet leaves the rifle. And we want to know how much work is done on the bullet if it starts from rest. How much work? Well, here's our work energy theorem. How much work? Work is what we want, so that's what we're going to include in our equation. Next question, do we use delta E or FD? Well, do we have any forces anywhere in here? No, we don't. They don't give us a force, they don't give us a distance. So we'll use change in energy, and change in energy is final energy minus initial energy. Now it's really important to notice what this problem says, that the bullet starts from rest, which is true of every gun. So if it starts from rest, that means our speed is 0, and if speed is 0, that means the kinetic energy at that point is 0. And we're not really considering potential energy at this point, especially because it didn't tell us how high the bullet was off of the ground. We're not considering that. So initial energy here is going to be 0. Plug in. Final energy is when the bullet is coming out of the gun. It's got kinetic energy at that point, and kinetic energy is 1/2 mv squared. The mass is 875. Nope, that was the previous problem. The mass is 0.005. Speed is 400 squared minus 0. Notice that this energy is the same as this energy, and you indeed come out with 400 joules of work. Again, highlighting our work energy theorem, that if we get to 400 joules of energy, we had to have done 400 joules of work in order to get there from rest. Work equals the change in energy. Lastly, if the work is done over a distance of 0.75 meters, and we want to know how much force is exerted on the bullet by the gun. How much force? So again, we'll look at our work energy theorem. We want to know how much force. We're trying to find the force. So that means we for sure probably better have a distance, and there it is. So FD is going to be part of this equation. And you can actually use either one of these. They're both the same in this case. We just calculated the work, and we just calculated, well, this is the energy, but it's also the change in energy, because work equals the change in energy. So let's just say work equals FD, just like our old school equation. So 400 is the work, equals force, times the distance of 0.75. Divide both sides by 0.75, and you get a force of 533 newtons.